Okay, so we are going to proceed with the past papers of sampling and estimation. Now here we go. This is the first question that what we are having right now on the screen. Okay, boss. Was the explanation good? Did you understood each and every concept, whatever I have given to you? I think so. That's great. I think so. That will be fine. Okay, so what we are having that leaves from a certain type of tree have a length that are distributed with a standard deviation of 3.2 centimeter. A random sample of 250 of these leaves is taken, and the mean length of this sample is to be found 12.5. First of all, you need to just extract the data from the question. Okay, so what they are telling you that there was exactly the population, and they have provided you the standard deviation. It means first you need to make a checklist for those, like for starting the question or just extracting the data from that question. Okay, is that clear? So sigma is known. Okay, and sigma is exactly 3.2 centimeter. Is that fine? Now next thing, they have given you the sample size of 250, means n is greater than 30 or n is any size. Is that clear? N is, or I can just write it like n is greater than equal to 30. Okay, then furthermore they are telling me the mean length of the sample is to be found 12.5 centimeter. So mean length is exactly 12.5, and there is no concept for remembering the mean. We just only go for the n and the standard deviation. Okay, so now I'm just going for the checklist, and they are asking about 99% confidence interval. Okay, so here we go. Normal distribution, variance is known, and n is any size. It means the case number one that we can apply. Okay. Oh, so it means that CLT not applied. We cannot use CLT. Like x bar follows a normal distribution with a mean it has given and the sigma over n, perfectly normal, and this is the formula for calculating z, and we have to construct a 99% confidence interval for this thing. Is that clear? So our x bar is this one, and furthermore what we can do, the confidence interval will be done by this way: x bar plus minus z sigma over under root n. Okay, this formula I'm using. And furthermore what they have exactly provided that 99% of the confidence interval for the population mean length, yes, yeah, so we can calculate the value of z now. Z we can also calculate. How we can calculate it? X bar minus mu divided by sigma over under root n. This is the formula, but there is a problem. They are telling me that it is 99% confidence interval. So 99% confidence interval means like alpha will be 0.99. And what is exactly the meaning of this confidence interval? The mean is over here, and this area is exactly the portion of the confidence interval, which is exactly 99%. Sorry bete. 0.999. I did not get your point exactly. Yeah, 1 minus 0.99 is exactly 0.01, and when I divide it by 2 it becomes 0.005, isn't it? This portion and this portion, they both are exactly 0.005, and it is exactly 0.005. Okay, and what is our sample mean? Sample mean is given, that is 12 point, sorry, okay. And what should be the value of z? What we can see, you 2.576. Do you know this thing, like where I put it, that thing, 99% confidence interval, so it means it's this one, 99, 99, and this one, 2.576. So z is exactly 2.576, and now for the confidence interval I can do that. X bar was 12.5 plus minus 2.576, and sigma was 3.2. Sigma was 3.2 divided by under root of n, and n was 250. So according to that condition, 12.5 plus 2.576, 3.2, 250, it's 13.02 for plus, and for minus what I'm getting, it's 11.97. So they're asking about population mean and so we can proceed with this thing now, like it can be 12, the lower value, and the upper value will be 13. Can I do that? Yes. Okay. Now furthermore, what they are asking, write down the probability, sorry beta, any distraction means how, air, wind, sound. Now it's coming a bit, just give me a second. Now check, it's still coming. Very less. Now I guess it will be fine. Okay, so what they are asking in part, that was part A, and in part B they are telling me write down the probability that the value of 99% confidence interval will lie below the population mean. That will be 1 minus alpha na, and 1 minus alpha 0.99 divided by 2, that's it. This is the portion they are asking about. Okay, 0.0. They were asking you, write down the probability that the whole of 99% confidence interval will lie below the population mean. What does it mean? Below the population mean means on the other sides. Like the population mean is over here, na? That is 12 and that is 13. So they are asking about this portion. Okay. So it will be exactly 0.005. What is it? When you subtract it from 1, what is it? We're getting 1 minus 0.99 divided by 2 is 0.005. 0.005, when you multiply it by 100, what is it? 0.5%, I guess. Yeah, 0.5%. This is the answer for part B. Okay, then we go to the next question. Okay, what they are asking in this question? Question number 2. It's a 3-mark question. Do you remember that when I was just explaining you the sampling, at that time I just introduced you a method of designing a sample, picking out the numbers? Hmm? Okay, they are asking us describe briefly how to use the random numbers to choose a sample of 10 students from a air group of 276. So you have to select only the 3 numbers. Okay, so how can you go with it? Like you have it in your calculator, no? The random number button. It will always gives you the 3-digit value. Okay, I'm telling you, like in your calculator, when you see there is a decimal, and above the decimal there is a button of random, RAN dash, this kind of button. Okay, it is for generating. Yeah, that will be fine. Black or white cover. Class is. Yeah, that is also fine. They all are same. No, it's not that much different. It's the same series. Generating random numbers. So our random number, when I put that value, no, so our random number will be definitely, you can say that it will be 0.959. Okay, so it will be in decimal 3. So you, if you are just going to find out that numbers, so you can generate the numbers and pick out that one. For example, how many students are there? 276. I'm just telling you know. That was the explanation which I was given. So now what I need to write now? Number generate a 3-digit random number. Okay, first step is this one, and now leave that numbers which are greater than 276. Okay, and also leave the Multiplication of numbers. Okay, and for example, if they are just telling you to just figure out the number, so do you know what you will do in the calculator? Like you will write random equal to by this command and multiply it by 276. Okay, and keep on pressing equal to one by one. For example, if I did 2 into 276, so I am getting 78. My first time, yeah, there's a times. Okay, so this number I can pick, so I just pick that one. Then again it is showing me 90, so I also can pick. Sorry, you get? Yeah, I just convert into the SD na, press SD, so it will get, just pick out the integer value. Okay, then I'm getting 171, then I'm getting 189, then we will complete that one till 9, 83, 84, 158. Are there 10? 1, 2, 3, 4, 5, 6, 7, 8. Two more. 129 and then 5. Got it? So I just pick out the 10 random numbers. Yeah, it's enough for 3 marks. That was exactly enough. This one was enough for 3 mark. 1 mark, 2 mark and 3 mark. That's it. Okay. This calculation actually I did it because when they ask you to calculate, figure out the numbers. Huh? So at that time you can proceed with this way. Okay. Hmm. So what is in the next question they are asking us? Okay, what they are asking? The length of a certain species of lizard are known to be normally distributed. Okay, so first we are going to make the checklist. The first point they have raised, that is normally distributed, and with the standard deviation it means sigma is known. A naturalist measures the length of the random sample of 100 lizards of the species and obtains a alpha percent is a confidence interval for the population mean. He finds that the total width of this interval is exactly 1.25 centimeter. Okay, so we do not know about alpha anything. Okay, but we know that the distribution is normally distributed, and we have sigma is known, and sample size is greater than 30. So according to the condition, normal distribution, sigma is known, and any size of sample. CLT is not applied. This way we are going to proceed. Okay, and they have provided us this, the width of the interval. Okay, so the width of the interval, sorry, PQ over, and that is for the proportion, na? No, it's not a proportion. Proportion is this one. PQ over under. I have wrote it over here, na? It's a confidence interval for the sample proportion. This is the formula for the width. So sigma is 3.2 n is 100, and then find the total width of the interval. Yeah, I also forgot. 2z sigma over under root n sample size. So width is 1.252 multiplied by z into sigma. Sigma is exactly 3.2 and 100. We can calculate the value of z from that part. So according to the condition, what I can say, 2 multiplied by 3.2, or we can just directly calculating the z. 1.25 multiplied by under root of 100 divided by 2 multiplied by 3.2. So our z will be, it's exactly 1.95, 1.953. So z is exactly 1.953. 0.9746. So alpha will be 0.9746. So it means it should be 97.5% confidence interval. 1.953. Alpha is exactly, isn't it? Alpha is 1 minus 0.99. Alpha is that portion. Yeah, na? The problem is alpha is always this one, na? This one or this one. So I just calculated this thing. Alpha will be 1 minus 0.9, and 1.953 is exactly this one. 9746, na? Okay, just a second. See this one. So this is your alpha. This is not alpha exactly. It's a value of z, 0.9746. Okay. So according to the condition, when I see the chart, the normal distribution look like this. So this portion is exactly having a probability of 0.9746. So according to the condition, 1 minus this is 9.6. And this will be alpha by 2. And this will be alpha by 2. So if I proceed with this one, alpha by 2 plus alpha by 2 plus 0.9746, it will be equal to 1. So it becomes alpha, which is exactly 1 minus 0.9746. And what I'm getting alpha, I'm still getting a wrong answer, I guess. Can you check the mark scheme for this one? Sorry. Something. Yeah, sampling and estimation. Document is sampling and estimation. Question 3, I guess. We did that one. 0.9746. So 0.9746 when you multiply it with by 2. Okay. Yeah, I got it. I got it. This portion, because they have seen the left side now, that is 1.953, isn't it? Yeah. This will be the mean, no? That will be the mean central value. So it means this portion, hmm, so it's this way, like 2 multiply with this one, 0.91 minus, and if you go with 1 minus 0.9746, what we are getting when we do that? Just a second. 2 multiply by this area, 0.0254. Okay, that is exactly I'm telling you. When you subtract that one, na, because when you see the value of z minus 1.953, 1.953, 1.953 will always be giving you the value for this part, na, till over here, isn't it? So according to the condition, when I'm proceeding with this one, let's see this. First, I need to figure out that value, no, this one. I have to figure out that confidence interval percentage, na, isn't it? Like this portion, this complete portion, and I exactly have the value which is over here. Okay, are you getting it? Like so this portion is 0.9746. So when you subtract it from 1, so you will be getting this portion. Okay, and they are two times, no, because one portion is over here and second portion is over here. When you add both of them and multiply by 2 and subtract it from 1, so it will give you this portion only, isn't it? Or we can do one thing. It directly can give you as well, because they are too lengthy. What should we call? थोड़ी सी लंबी कर दी उन्होंने. This है. It's like this 1 minus 2. So if you are just getting this one, na, like this one 0.9746. So when you subtract it from 1, you will be getting this value, and you can just directly subtract it from this way, like 0.9746 minus 0.0254. So you will directly get that value, 9492. Okay, or either you wanted to go with this way, it will give you the same answer. Okay, fine. Did you get it? Okay, so when I apply with this one, so the percentage, na, 100%, so it's going to be 94.9, so which is approximately 95%. Is it 95% over there? Yeah, I got the same. Okay, now what we are going to do in the next question? Question number 5. No, question number 4. A construction company notes the time T days that it takes to build each house of a certain design. The results for the random sample of 60 such houses are summarized as follows: sigma t and sigma t square. Calculate the 98% of the confidence interval of the population mean. Okay, so we have to go for the 98% confidence interval right now. So first of all, I am not having exactly, so we can calculate the estimated mean by this way. They're not telling us estimated mean, and we have done this thing over here, and we can calculate the confidence interval of the success population mean and by the estimate. So true is not there, true is there, sorry. And this is the simple sample. It's x bar. So x bar can be calculated by 4820 divided by 60. What we are getting, beta? Sorry, 80.3. So it is going to be an estimated x bar. And what about the variance? Huh? Like sigma square, it can be, sorry, beta. Yes, there's a formula for this one, and I have wrote it, I guess. Yeah, this one, no? This one. This kind of data you are having, no? It's very simple. I'm doing it. That was a population mean. Have you done it? You have done that. It is estimated, no? 1 over n minus 1 or n upon n minus 1. They both are same. MF19 is not having. I didn't get your point. What is it having? MF19. I did not. Hmm. All square root. And they are not using 1 upon n minus 1 or n upon n minus 1. It's an estimate, na? So they must use this one. Es- so it will be 60 over 59 and 392050 divided by 60 minus mean what we got 80.3 square. Okay, and it's up to us that what we are going to do, like we are going to put that directly this one, or we can directly put this thing over here as well. Okay, what is the estimated variance we are having? Is it still noisy? No, no. When I'm saying at the time also noise, not noisy. 87.54. 87.54. Did you check it from this? Yeah, exactly. Sometimes it happens that no, like we are having 2050 because we have rounded that estimated mean. So maybe, yeah, because I rounded that one, no? That's why 82.1. So I think we should write it over here like use 4820 divided by 60 square. That will be fine for this thing. 82.1. Okay, so we got the variance estimate. Now what we are going to do, calculate a 98% confidence interval. Okay, so at that time, what kind of data we are having? Not normal, it's understood. uh, this one, case number 4, this was a cap. Now it's an estimate because the data is not normal. Sigma square, oh no, not normal, this one, sorry. Yes, you have to memorize, that's why I have wrote it. I also, before teaching you, I just made the notes for myself, and after that I have taught you, because it is very complicated thing to remember that particular stuff. What was our n? In over here, yeah, this is sigma is known and that will be sigma is not known. So we are having case number 4 right over here. CLT will be applied in this case, because I made a mistake, I wrote it not known, no? Because sigma square is known, so CLT is not applied. Sigma square estimate is not known, is known, so we cannot apply the CLT. So over here, this is the thing. This is case number 4. Yeah, but we have already done that thing, no? Do not need to just go for the CLT, because we have to go for the confidence interval, and we have used the estimated, so no need for this one. What is estimated mean is 80.3, and just check it again now. 484820 divided by 60, 80.3333. Should I write it? Should I write? I think I should write like this now, because it's a recurring number that I'm having. So maybe the final answer will be having some. Yeah. And what about the confidence interval? 98%. You know, you need to make that chart every time showing your calculation. It's a part of the calculation. Sorry. They will not give you the extra mark. They will not give you the extra mark, but they will deduct 1 mark overall if you do not follow this now. 98%. So the value of z must be 1 minus 0.98. What are you getting? 0.01 and 0.01. And what about the 98% value of z? Zero point 0.98 is, there is when you add 2, no, 9, 7, 9, 8 and 2, it will become 980. 2.54. 2.64. No, 6 will be this one. And any another value which is less than that, if we add 2 over here, and if we add, yeah, 2 is not possible, 3 is not possible also. It's too far now. 9, 3. Yeah, I guess this one. 2.54 I'm getting. Okay. And there is also the way for the interpolation. Do you know that? Interpolation. Sorry. This is a node and this is 1.96. So x minus 1.960 divided by 2.326 minus 1.960, 0.98 minus 0.975 and 0.99 minus 0.975. Are we going to have the same answer? Yes, exactly. It's easy. Just a second. 2.02, I'm getting a different thing over here. We got the 98% now. Hmm? Just use that one. 98%. What you got? 2.54. Okay. 2.54. Okay. Then furthermore, what we have to do? Confidence interval. And the checklist is already done now. What was the N? 60, 60, 60. If you go with the checklist, so you will get the same answers. Same thing. Like it's not normal. Okay. An estimated is known. No, is not known. That was not given. Na? I calculated it. And N was greater than equal to 30. Okay. So the confidence interval will be having estimated mean plus minus the estimated variance divided by under root of n. So x bar is exactly 4820 over 60 plus minus your z is 2.54 and sigma square we calculated 82.1 divided by under root of n. Under root of n is 60. Hmm. Really? 107.25. What was the 99% confidence interval value? That was a sigma, no? Not a sigma square. What I'm doing? We calculated. Oh, I was getting a large value of mean. Yeah, almost in that portion. 83.3, which is approximated to 83 or minus 77.3, I guess, which is exactly 77 almost. Okay, so the 77 and 83, these are the limits for the mean. And over here, explain why it was necessary to use the CLT theorem in part A. It's very simple, no? CLT theorem is applied when the population is unknown, when it is not normal. It can't go from binomial to. I didn't get your point exactly. Yeah. It's exactly like this. Let me tell you. You have, I guess, put it somewhere when the CLT is going to apply. X is not normally distributed now. So there is a multiple options that we use the central limit theorem, and at that time X bar is normally distributed, we considered it. And this is the Poisson distribution, we convert that into the normal, and this is the binomial distribution will be converted into normal. That is over here which I wrote it. Okay, I explained you this one because of that. Like N and P, sometimes they provide us the N and P. Okay, we have this kind of question, and sometimes they provide a Poisson distribution with a lambda. Population distribution is not known. Maha, you cannot use this short forms, okay, beta, in the paper. I am using it right now, but you cannot write it in the paper. Okay, what is he asking in question number 5? Will you be available on Thursday? What time? Actually, the thing is, I am thinking that we should do some more questions. So I am thinking, that's my observation, that we should, in the next class, we should proceed some of the questions of this same sampling and estimation. And in the next class, we start with the hypothesis. Okay? So, Thursday, no? Thursday at 11:30, mine. Will you be available? and tomorrow is 11:30 as well. Okay, tomorrow is a Wednesday. No? So now what they are asking us, they are asking us to do the length in millimeters of the random sample of 12 rods made by the certain machine, and what they are exactly asking. Find an unbiased estimate of the population mean and the variance. So this is the sample exactly, na? Why they are just irritating us? We will be getting the estimated mean by adding all the numbers. Two three nine eight divided by 12. The estimated mean I am getting is 1, and it's again like this, a recurring. Okay, and if I have to use, I will use this one. And the variance estimate will be 12 upon 11, and the squares. Do you know? You can do the. Should I tell you or not? It is allowed. Do you know you can just save the data and you can directly get the x square values? You there? You know that? How to do this? Okay, just let me know. Press the mod button. What you are seeing on your screen. Your voice is too low. Yeah, much better. Press the mod button. What you are seeing on your screen. Yeah, press 3. Press 3. Now what you are seeing. Yeah, press 1. Press 1. Okay. Now store the values one by one. 200 equal to 201 equal to 198 equal to, and keep on storing all the values. And 12 values are stored. Now press the button of AC, not on. Press AC button. Okay. Now press shift and press 1. What you see on your screen? Sum. Go to the sum. 3. Now what you see? Hmm. Yeah, that's a word. Expected x square. 479226 divided by 60 minus 2398 divided. Oh, 60. Why 60? It's 12. Steps forward. Mm. And then keep on putting the values. Then press shift and 1. I can directly calculate the means and the standard deviations, but do not apply in that. Just like a wrestling, na? When we see, do not apply it at home. Do not apply the papers. it's again 2 point. Is there an SD form? No, there is no SD form. 2.333. I'm just taking 3 or 4 values because I'm getting the recurring answer. Maybe it will not affect my calculation. Okay. So unbiased estimate of the population mean and variance, we have done that. Give a statistical reason why these estimates may not be reliable. Why? Why do we, just my question, why do we take the estimated mean and the variance? That is important question first. Mm, no. The estimated mean and the variance is calculated when sometimes we do not know about the distribution. Okay. And the second thing is, like, the sample should be very large. Okay, got it. So at that time we are using that estimated mean and variance term. So now over here, when you see this question, so there is a very small sample size. What is it? It's 12. Yeah, no? So it means they were asking, give a statistical reason why these estimates may not be reliable. Yes, small sample size. Okay, no, I thought that you were saying no, not okay. Question number 6. A random sample of 500 households in a certain town was chosen. Using this sample, a confidence interval of the for the proportion P for all households in the town that owned 2 or more cars was found to be. It's a confidence interval they have provided us, 0.355 and 0.45445, and it's a proportion confidence interval. Find the confidence level of this confidence interval, giving your answer correct to the nearest integer. So what they are exactly asking? Yeah, it always. It's not an English exam, is it? Okay, what is they are asking about? The first thing, which is very important, that we do not know exactly the proportion estimate. Do we have? We have nothing. So now, according to our knowledge, whatever we know, now it's a game of knowledge now. So these are the values over here. What they are talking about, like the central value will always be the mean. Proportion, you can say that because it's a proportion now, so I'm writing it proportion estimate. Okay, so it's a proportion estimate. This value must be 0.355 and this value must be 0.445, isn't it? So if the proportion estimate is in the middle, so it's easy to figure it out, no? Because we know that in maths we have studied, like, if we add both of them and divide it by 2, so it will give me the central value, isn't it? It's a zero point 0.4. That is my estimate, proportion estimate. Okay, now I'm going to proceed according to that condition. The confidence interval, the percentage, no, confidence percentage, probability, not exactly the normal thing we follow, because This is exactly this one, bete, this one. Sample proportion confidence interval. It always follows the normal distribution, no? And according to our checklist, if we are talking about, so we have this one and we are having this condition, n is greater than or equal to 30, isn't it? Because n is 500. So we can proceed with this one. Should I start now? Okay. So now for your recall, I am just writing the checklist, okay? The checklist is proportion estimate we have, that is 0.4, okay? And the second thing, that n is greater than or equal to 30, okay? So when we are leading with the proportion, so we know that proportion will always be following the normal distribution, okay? So now its PS is 0.4, so what is my QS? 0.6. Hmm? So when my proportion estimate follows a normal distribution, so it is going to be the proportion and proportion sample failure over n. Your voice again very low. Oh, oh. And for the confidence interval, if I'm talking about, so it must be proportion plus minus z p s q s over under root of ns. So I'm getting 0.4 plus minus and up the value for z, what it should be. We do not know that. Do we? Yeah, we can find it. I'm telling you how. Just give me a second. So it must be under root of 500 that we are having. PS was not there. Yeah, this one, it's a plus minus under root. I made a mistake. Where? Not here. Just I did not. Thank God I did not calculate. The root is over here. No? The whole term will be having a square. So now what I can tell you, like 0.4 plus z under root of 0.4 into 0.6 divided by 500 will be equal to 0.445. You got the confidence interval. Do you remember? And this will be 0.4 into 0.6 divided. What was it? 335 now. Now we can calculate the value of z, but the value of z will be same from both of the parts. Huh? So you can, yeah, do any one of them. Like I'm using the plus one, or you can use the minus one as well. No, 0.445 minus 0.4 divided by z is exactly 2.054. What I'm getting. Okay. So what is exactly the value of z 2 point? You can tell me. 0.054, it's a 0.98, so it means still over here. If I'm talking about now, like this whole portion is exactly 0.98. So from this part it's 0.98, so I need this one. This one will be 1 minus 0.98. What is it? 0.02. It's a two tail, but you check the value for this one, na 2.054. So I just, there is another tail is over here, because it's a confidence interval, na, it must be two tail. So what we can do, 0.02, I can directly do that here. 0.98 minus 0.02. What is it? I figured out that value. That value will be same over here, na? So I use the whole and subtracting this part to figure out this portion. 0.96. So it means it is going to be 96% confidence interval. Fine. Can you keep till here? I'm so tired. So we will proceed some more questions in the next class, and then after that we will directly go towards the estimation and hypothesis testing. Sorry, hypothesis testing. Okay, okay. See you. Take care. Allah Hafiz.